Hello. So we are going to again do some circuit analysis, and I hope you enjoy as much as I will. We are going to start with I didn't actually put this on the page, but it looks like an interesting circuit to me. Figure 4.24 on page 234 of Art of Electronics. So I am going to just draw it out here. Resistor, resistor, and one more resistor. Right there. Okay. Yes, now op amp. Active building blocks. Let's have the minus on top. Like that. Put it down there like this. Then, yeah, we need a ground. Ground there. Now basically, well, we put four different voltage sources as well. This is what they call a summon amplifier. I mean, I guess that gives away sort of what it does. I'll still go through it, just because I don't want to say, oh, this is the answer. That'd be no fun. Let's add a test point. Right there. Now, we will draw add wire there and go there. Go there. Now, just go there. We can connect this over to ground. Oh, yep, we have to add a resistor there too. So this resistor here. Oh. My dog's come to join me. She thinks that I need help with making circuits, which I probably do. I don't think she's going to help me much, though. They just made all these 10K. Okay. So, let's analyze what's going to happen here. So we have three, like a 10K. Let's analyze each of these separately, actually. So this 10K here will apply that 5 volts. Now we want, like this input here will want to go to 0. Because this ground is right there at 0. So that means that there is going to be, well, there has to be, what would that be? A half a milliamp traveling through this wire for this full 5 volts to go to 0. So that means that a half a milliamp from this part here will have to be going through this 10K as well. So that means that there must be minus 5 volts here. It's based on this one. Now, if we follow that, again, we'll say 1 volt here, and then obviously a tenth of a milliamp has to be flowing through. So that means that there must be minus 1 volt. So then there's minus 6 volts. Again, following that logic, 3 volts, 0.3 of a milliamp. That means there must be minus 3 volts here. So my anticipation is that we will have minus 9 volts right there. So let's run this. And I am right, minus 9 volts. Guess that that circuit isn't as nice as I thought it was. But we have that now. So let's, if there's any questions, I guess you could ask them. But I probably will move on to the next circuit, which is going to be 4.25 on page 234 again. So we're going to stay on the same page, but we're going to go to the next figure. Yeah, let's just delete this off now. Draw. And we'll add another active building block, this time the plus on the top. There. Did I not do this one already? It says I didn't. So now I need to add resistor. Put one there. I'm sure I actually did this one. I don't know. I mustn't have crossed it off. If you tuned into my previous video, you'd probably be able to tell me that I did it. So, but anyways, this 10K here, they put 10.0K. So that just means that they basically are using a 1% resistor, I'm guessing. Like a very high precision one, or somewhat high precision at least. This one, they put it at 1.10K. So the same sort of precision as that 10K. I'm not going to put that in, mostly because I don't want to. Yeah. So I'm guessing this will be the, oh, oops. Inputs and sources. Voltage source, there we go. Right there, 5 volts. Oh, wait, we better stop it here. Then it wants an NPN transistor, active components, NPN. Yeah, I just am making a thing for work. It uses I'm gonna probably use an NPN transistor in it, along with other things, but I'm just learning about some more experienced people were telling me about, oh, you need to do this for circuit protection and such, because well, or else it might get fried, which I hadn't really considered. It's a sort of an alarm circuit. Well, it is an alarm circuit for my job, and then it will, like, if you flick at one switch, sorry, here, I'm just, there, this one is what I want. Inputs and outputs, I will put that there. Now we'll draw the grounds. And ground right there. And right there. Okay, so now we are finished with this one. We're constructing it. So let's just sort of think about it for a second. I'm gonna just up that to 10. So this is at 10 volts here, so you can see. This will be at 5 volts, so we know right away that this point here will want to also be at 5 volts. So that means, what does that mean? Sorry, I'm just thinking here. Since this is the non-inverting input, this will apply a positive voltage, some sort here. Oh yeah, I guess I should also add our test point right there. So we have our test point right there. So this is what they call the output. So we know no current will be flown out of here, based because we're using a perfect op amp. So that means that all the current that flows through these two will come from here. So effectively, this 10K and 1.1K is in parallel with this one. Yeah, it looks like you all are buffering right now. I'm looking at the YouTube Studio, whatever thing. Oh, there, now it looks like you're back. Okay, but yeah, what I was saying was that these two are effectively in parallel. So whatever this we know will want to be 5 volts. So when this is turned on, it will bring whatever it needs to make this 5 volts. So that means it is going to be, so it'll be 11, like 11.1K. So, well, we know, yeah, okay, that's better how to figure it out. So we got 5 volts going through here. That's what, roughly 5 milliamps. Means that 5 volts go through here. So roughly 10 volts here, I would say. Let's just check. Max current exceeded. What did I do again? Oh, this, I think. Maybe. Let's draw a resistor right here. I did this last time, I remember, too. Oh, max current exceeded. I think, yeah, no, this wasn't the problem. It was over here for some reason. Not reset. No, it's actually this. I think we need one just here, and then we'll be fine. Sorry, I forgot. I think, yeah. Put you here. Go there. There. See, now it's working fine. Sorry about that. That I forgot how to. Um, so what was happening there was that I wasn't basically sending unlimited current into this base, which isn't very good for the base. But now we have it working correctly. And as you can see, now I know they are trying to get to a more precision or a more precise circuit, and what I talked about wasn't as precise. The reason I know they were trying to get to be more precise is that they did quote like this 10K as 10.0K and this 1.1K as 1.1 OK. So that means that they were trying to get, I don't know, a pretty precise circuit. And how I estimated it was I said, oh, we'll just call this, this one right here a 1K. And we know 5 volts are here. And we know that the current must be flowing this way because no current will flow out of this. And this must go to ground. So we know that there must be 5 volts going through this 1K. And I said, well, that means 5 milliamps. I said, well, if we have 5 milliamps traveling through here, then that means we have a 5. Wait a second. So that's only 1 milliamp. 5 volts. Oh, this is maxed out. Let's go to 25. 25. Apply. Okay. So that's still getting. Sorry, I'm just trying to figure out what's going on here. So to edit this, go to 50. 50. Okay. There, now we get it. Okay. Let's turn this down to 1. Yeah, so it's a gain of 10. Yeah, sorry, I was just I made a mistake there. Obviously, as you can see. Because yeah, 5 milliamps. If that was to be 5 milliamps, so that means like we got there, and then we go through the 10K. Well, that means we're actually asking for about 50 volts right here. Which we weren't getting because, well, we didn't have the circuit set up that way. See, now we're getting a bit closer to that. Yeah. Sorry about that. I understand that now. That's one thing I always think about is that it's always better to, like, when you're dealing with op amps and you're wanting to figure out what their behavior is, it's better to apply smaller voltages to the circuit, just because if you apply large voltages like that 5 volts, you can get some really weird outputs. and that's not very helpful. Can already tell my voice is starting to go a little bit. So I don't know how much longer this stream will last, but I'll go for a bit longer here. So let's go to page 239 of Art of Electronics, and we'll do page or figure 4.39. Oh yeah, this was one I was infinitely confused with. Initially, I've analyzed it once before, so hopefully I can figure it out again. It is a triangle wave oscillator. Let's dive in here. It was just I really was confused with it. The first time I saw it, I had to talk with my electronics tutor for a long time until I finally got what was happening. So let's go here, put in that resistor, edit, and 124. Oh, oops. 24. Okay. There we go. And then we'll put a add ground right there. Draw passive components, capacitor. Put a capacitor right there. Just make it into a little capacitor. We don't need a very big capacitor. Oops. Didn't you have it highlighted there? And then we need a 2K resistor right here. And we'll put another 10K resistor right here. Here we go. Now we have to put the ground in on this one. Right there. Okay. Now I think we mostly just have to draw in all the wires. Then we'll get to the analysis right away. Again, this one is the figure 4.39 on page 239 of Art of Electronics. And yeah, might as well put it as a separate wire. This is gonna be the test point. And I'll probably put this test point, I think, right in the scope. View in new scope. So now we got a scope. Yeah, so this is an oscillator. So what I might do is I probably will have to give it a push. Let's go. Oops. Add voltage source. Voltage source, one terminal. Let's go here. Can I edit this? DC form, sawtooth, pulse. There. Okay. So let's just assume, because this is a oscillator, let's assume a voltage. Assume that this is output in a square wave. Okay. So assume that it is output in 5 volts there. Say. So now we got 5 volts. And that means that over here, this is going to be less than 5 volts. It's going to be, say, I don't know. Something like, let's say that this is at 2 volts. And then it's going to try and take it to 0. And since that's the invert in input, that means that it's going to be, say, minus 2 volts here, and it's going to be rising. So it's going to slowly become more than minus 2 volts. That means that over here, we also see that minus 2 volts. Since that's a minus there on the non-inverted input, and the inverted input's at 0, we are going to continue to try and bring this non-inverted input up to or down to up to 0 by outputting the same. That's minus 2 volts. You see, I knew I might get confused again. Let's run this. Really? Reset. Run. Nope. Draw. How's that syncing? Did I do something wrong again? Let's see. I draw. I just want to try and prompt this into oscillation. So let's see if we can quickly there. Now we have it. Let's go horizontal scale. We will decrease that. There we go. Okay. Now, sorry. You see, we are getting what we expected, a sawtooth. So yeah, we see right now, this is rising. Oh, now it's falling, and then we go back. Here, let's go. This is gonna slow it down even more. Yes, now we see. Let's go minus, and then This is going to a minus 15 volts. That's at 15 volts. So this is at minus 15 volts here. Now over here, we are outputting positive. That's now we're at 15 volts. Okay. So let's just walk this through again. Okay, let's stop. So we're at minus 3.7 volts right now. Then right there, it's outputting minus 15 volts because there's no feedback, eh? So that just means that it's gonna basically slam it to one end, like to its maximum rail. But then we go through here at minus 15 volts and 15 microvolts there. Now what's happening? Oh. I think I see what's happening. So that's at 0 volts. That's at 15 microvolts. Let's edit this. Cancel. Let's just run this again for a bit. So this is always in the microvolts. I think that must be. Okay, I'm going to give one more shot at this and then I think I'm going to call it because my nose is getting right all stuffed up. And yeah, like I don't know how many of you've seen this before, but usually I go for about an hour. But I've been a bit under the weather today. So right now, this is applying 15 volts because over here is some positive voltage. Now we've switched, we're at the negative voltage. And then over here, we are seeing a slight negative voltage. Now we're seeing a positive voltage. So that's going to be moving this one. Okay, let's stop here. So now we're at 2.7, so 2.8 volts. And over here we're at negative 27 microvolts. Oh. I think I'm gonna read about this one again before, but I think like basically what's happening here is that this output is charging this capacitor, and there's some small voltage here that changes it back and forth, and that affects this here. But anyways, thank you for watching this. Sorry it wasn't as good as previous ones. Might revisit this circuit next time. But anyways, thank you for watching, and yeah, hope you join sometime else as well.